Welcome to this deep dive into console I/O and debugging outputs in Unity, with a special focus on Debug Log. If you're a beginner just starting out in game development, this comprehensive step-by-step guide is designed to help you master the essentials of using the console for effective troubleshooting and logging information that can save you hours of frustration. We'll thoroughly cover the foundational basics, walk through practical demonstrations with real code examples, and share essential tips to kickstart your journey in Unity development. Understanding the importance of these tools cannot be overstated, as they allow you to monitor your code's behavior in real time, identify bugs early, and ensure your projects run smoothly without unexpected crashes or glitches. In this tutorial, we'll provide a detailed step-by-step approach to grasping these crucial development tools, starting from the ground up, so even complete novices can follow along confidently and apply what they learn immediately. Throughout this tutorial, we'll dive deep into the basics to build a strong foundation, provide hands-on practical demonstrations that you can replicate in your own Unity projects, and share some essential tips that experienced developers wish they knew sooner, all to get you started confidently on your exciting game development journey with Unity. Let's begin by opening Unity on your computer. Once it's fully loaded and your project is ready, navigate to the console window, which you can easily access by going to the top menu. Select Window, then hover over General, and finally click on Console to open it up right there in your workspace. Console I/O essentially refers to the process of input and output operations happening directly through this console window, serving as a fundamental tool for debugging your Unity projects by allowing you to peek behind the scenes and observe exactly what's happening in your code during runtime, from variable changes to function calls. We'll start our exploration with Debug Log, which is a simple yet incredibly powerful method to output custom messages straight to your console window, acting as your very first line of defense for gaining a clear understanding of how your code is executing step by step in real time. To see it in action, go ahead and create a new C# script in your Unity project by right-clicking in the Assets folder and selecting Create C# script, then attach it to any game object in your current scene, such as a simple cube, and inside the Start method, carefully type out Debug Log to print your first message. Now, hit the play button to run the scene in the Unity editor. You should immediately notice Hello World popping up as a fresh entry in the console window below, confirming that your first successful log output is working perfectly and demonstrating how quickly you can start seeing results. To keep your workspace organized and prevent the console from becoming cluttered with old messages that could confuse your debugging process, always make it a habit to clear the console before testing any new code changes. You can do this easily by locating and clicking the prominent Clear button right at the top of the console window, which instantly wipes everything clean for a fresh start. Now that you're comfortable with the basics, let's explore the different types of debug log methods available in Unity. Besides the standard debug log for general messages, we also have debug.log warning for cautionary notes and debug.log error for serious issues, each designed to handle various levels of feedback in your development workflow. These specialized variants are particularly useful for quickly indicating potential issues or critical errors right within your code, as they provide immediate visual cues in the console that help you prioritize what needs attention first, making your debugging sessions far more efficient and less overwhelming. For a practical example, imagine you're tracking a character's status in your game. You could write something like debug log, where health is an integer variable set to, say, 100, allowing you to monitor its current value dynamically as the game progresses and catch any anomalies early. Take note of how these messages are color-coded for clarity. Warnings will stand out in a bright yellow color to grab your attention without alarming you too much, while errors are prominently highlighted in bold red, making them significantly easier to spot, prioritize, and resolve quickly amid a sea of console entries. Beyond simple text, you can also log a wide variety of data types directly to the console, including integers like 123 for numerical values, strings such as hello for messages, and even entire objects like a game object to inspect their properties and current state during runtime, giving you comprehensive insights into your project's behavior. In scenarios where something might go wrong but isn't immediately game-breaking, reach for debug.log warning to flag non-critical issues that still deserve attention, such as a resource like ammo or energy nearing depletion in your game, alerting you without halting the entire execution flow unnecessarily. On the other hand, reserve the more urgent debug.log error for genuine problems that could halt execution or cause significant disruptions to your game's functionality, like detecting a missing essential component on a key game object, ensuring that critical failures gain immediate visibility and demand prompt fixes. As we progress to more sophisticated methods, let's discuss logging with context, a technique that allows you to pinpoint exactly which specific game object or component in your scene is producing a particular log message, adding a layer of precision that's invaluable in complex projects with many interacting elements. You can implement this enhanced logging by simply modifying your call to debug log, where this refers to the current script's instance or the attached component, thereby making your debugging efforts much more precise and traceable back to the exact source in your hierarchy. Another incredibly useful approach is conditional logging, which lets you control when messages appear. For example, you might write if debug.log warning, so that the warning only triggers and logs the message precisely when the player's health variable drops below the threshold of 50, avoiding unnecessary outputs. By incorporating these conditional checks into your scripts, you effectively reduce console spam and clutter, ensuring that only the most relevant and timely messages are shown when specific conditions are met, which keeps your console clean, focused, and easier to navigate during intense debugging sessions. To further enhance your logs for better analysis, consider adding timestamps by including time in your message, like debug log. This simple addition helps you track the precise sequence and timing of events in your game, which is absolutely invaluable for diagnosing tricky timing-related bugs or synchronization issues. Moreover, don't overlook the powerful built-in filtering options available directly in the Unity console, such as the search bar for keywords or drop-down menus to isolate logs by type, script name, or even custom categories, all of which make managing and sifting through large volumes of log files much more straightforward and less time-consuming. When thinking about optimizing your code for real-world deployment, it's wise to wrap your debug log statements inside preprocessor directives like hashtag if Unity_editor to conditionally include them only during development, ensuring that these logging calls don't inadvertently impact the performance of your final shipped game builds. This precautionary measure guarantees that your debug logs remain fully active and helpful when you're running tests in the Unity editor environment, but they are automatically stripped out and excluded from your optimized production builds, thereby preventing any unnecessary performance overhead or bloat in the released version of your game. To make all this knowledge stick, let's apply these techniques in some real-world scenarios you might encounter. For instance, you can effectively debug player movement mechanics by regularly logging the player's current position with a line like debug log, which updates as the character navigates your scene. Similarly, collision detection becomes a breeze when you log events triggered by functions like onTriggerEnter, such as debug log, providing you with immediate, actionable feedback on how objects are interacting in your physics-based simulations or gameplay mechanics. Monitoring UI interactions is yet another common and practical use case for debug log, where you can confirm and track events like button presses or slider adjustments by outputting messages such as debug log, helping you verify that your user interface responds correctly to player inputs. As a hands-on example to tie it all together, consider this simple project setup. We have a basic cube game object that's programmed to move around the scene autonomously, and through our script, we're continuously logging its updated position coordinates along with any collisions it encounters with other objects in the environment. This real-time logging setup empowers you to observe and analyze exactly what's unfolding in your scene moment by moment, offering invaluable insights into your game's underlying logic, state changes, and potential issues that might otherwise remain hidden until they cause bigger problems later on. For even deeper levels of investigation when a simple log isn't enough, try combining debug log outputs with strategic breakpoints set directly in Visual Studio or your chosen IDE, which will pause your code execution at key points so you can meticulously inspect variable values, call stacks, and memory states in detail. To elevate your logging game, here are some best practices worth adopting right away for more effective and professional debugging. Start by organizing your logs through clear categorization using descriptive prefixes like player for character-related messages or UI for interface events, which makes filtering and searching them a breeze later on. Another critical guideline is to always avoid logging any sensitive data that could potentially compromise user security or invade player privacy, such as personal identifiers or encrypted information, especially when preparing your game for public release on platforms like Steam or mobile app stores. If you ever find that your expected logs aren't appearing in the console as anticipated, take a moment to double-check your current console filters to ensure they're not hiding messages, and also verify your build settings in Unity to confirm that logging is enabled for your target platform and configuration. Furthermore, stay mindful of the performance implications that come with logging. Excessive or overly frequent debug. Log calls can accumulate and significantly slow down your game's frame rate or overall responsiveness, so use them judiciously, perhaps limiting them to key events rather than every frame in loops like update. To round out your debugging toolkit, consider integrating debug logs seamlessly with Unity's built-in profiler tool, which provides a broader view of performance metrics and allows you to correlate log timestamps with CPU spikes, memory usage, or rendering bottlenecks, enabling more comprehensive analysis beyond just textual messages. In conclusion, mastering debug. Log truly makes it your best friend and go-to ally when it comes to debugging in Unity, offering a versatile, accessible way to understand, monitor, and troubleshoot every aspect of your code with precision and ease throughout the development process. I encourage you to go ahead and practice with all the examples and techniques we've covered in this tutorial, experimenting in your own Unity projects to build confidence, and don't hesitate to dive even deeper into the official Unity documentation for more advanced techniques, features, and best practices tailored to your growing skills. Thanks so much for watching this tutorial from start to finish. I hope it has equipped you with the knowledge to tackle debugging challenges head-on. Happy coding, and may all your future debugging sessions be swift, insightful, and free of those pesky, hard-to-find bugs.